Hey everyone, welcome back to the deep dive. Today we're tackling something a little different.
Yeah, a little
We're
different.
going to be prepping for
An AI.Code.Cast challenge.
yes. You've signed up to be a speaker, right?
I have, yes.
Okay, awesome. So let's jump right into it. What's the challenge all about?
So imagine you're given a schedule packed with all sorts of events like uh, conferences, hackathons,
Okay.
all that good stuff.
Yeah.
Each event has a start and end time, and then there's a value assigned to each one, too.
Okay.
Like prize money, maybe some learning points, or just, how fun it is.
Yeah, it's like a fun factor.
Exactly.
Okay.
So the challenge is to pick at most 2 events that don't overlap.
Okay.
So you can actually attend both. And these 2 events need to have the highest combined value possible.
Gotcha. So it's all about like strategic scheduling.
Exactly.
Okay, cool.
Yeah.
So let's say I was going to just jump right into coding this thing.
Okay.
Where would I even start? Would I just like try every single combination and see what gets me the biggest number?
Yeah. I mean, that's the brute force approach.
Okay.
It might work if you have a really small set of events,
Okay.
but it's not going to be very efficient as the number of events grows.
Yeah, because the more events you have, the more combinations you got to check.
Exactly.
Yeah.
And the longer it's going to take.
Right. Okay, so brute force is probably not the best way to go.
Probably not the best, yeah.
What are some other approaches we could look at?
Well, the source material you sent over mentions dynamic programming and greedy approaches.
Okay, those sound cool, but can we break those down a little more?
Sure.
I'm not really sure how they apply to this problem.
Absolutely.
Yeah.
So let's start with dynamic programming.
Okay.
It's all about breaking down the problem into smaller subproblems and solving them individually.
Okay.
And then you store those results so you don't have to calculate them again.
So it's kind of like we're making a cheat sheet or a lookup table as we go.
Precisely.
Okay, cool.
So one way to implement dynamic programming for this is using what's called a suffix array.
Okay, I've heard of those.
So imagine a table that tells you the maximum value you can get from any given event onwards.
So if I'm understanding that right, it's like it tells you the best possible outcome from that point on.
You got it.
Cool. So how do we actually build this suffix array?
We can work backward through the events
Oh.
and calculate the maximum value at each step.
Okay, that makes sense. But how do we use it to actually pick the events?
Right. So once we have our suffix array, we can loop through each event, and we can use something like a binary search to find the next non-overlapping event with the highest value.
Okay.
And then we just compare the value of attending only the current event versus attending the current event plus the best subsequent events from our suffix array.
Okay, so dynamic programming is pretty powerful.
It is.
But now I'm kind of curious about this greedy approach.
Yeah.
How is that different?
So a greedy algorithm basically makes the best choice at each step without really thinking about the big picture.
So like if you had a jar of cookies, you'd always grab the biggest one,
Exactly.
even if a bunch of smaller ones might be better.
Yeah, sometimes it works out, sometimes it doesn't.
Okay, so with the greedy approach, we might not always get the absolute best answer,
Right.
but it could be a much faster and easier way to do it.
Exactly.
Okay, so how would that actually work for this event problem?
So one way to use a greedy approach here is you could sort the events by their end times.
Okay.
And then you just go through them one by one
Okay.
and pick the event with the highest value that doesn't overlap with anything you've already chosen.
Okay, so both of those seem like pretty good options.
They are.
Dynamic programming and greedy approaches, what are some things we should consider when we're trying to decide which one to use?
That's a great question. So you always got to think about the constraints.
Right.
Like how many events can we choose? What's the size of the list and how much time do we have?
Yeah, like if we only had a few events, maybe the greedy approach is good enough.
Right, exactly.
But if we need to find the absolute best solution no matter what, then dynamic programming might be the way to go.
Yeah, you got it.
Okay, so there's no like perfect answer. It depends.
Exactly. It all depends.
Okay, cool.
Yeah, so let's shift gears a little bit.
Okay.
One thing that trips people up is handling those event overlaps.
Oh, yeah.
It seems easy, but there are some tricky situations.
Yeah, you can't just look at the start and end times.
Right. What if one event ends right when another one starts?
Oh, that's a good point. Is that an overlap?
Yeah, it depends on the rules.
Right, like what if you need time to get from one event to the next?
Exactly. You got to think about those details.
Okay, so overlaps can be tricky.
They can be.
What else should we watch out for?
Another common mistake is forgetting about that at most 2 events rule.
Right.
People might write code that always picks 2 events, even if picking just one would be better.
Oh, yeah. You got to make sure your code can handle picking just one event. Okay, good point.
Yeah. And then there's the issue of ties.
Ties.
What if multiple combinations give you the same maximum value?
Does it matter which one we choose?
It depends on the rules again.
Oh, okay.
Sometimes any solution is fine. Sometimes there might be extra rules to follow.
So we got to read those instructions carefully.
Always read the instructions.
Okay, let's try a little example to make sure we get all this.
Sure.
Let's say we have just 3 events, a conference, a hackathon, and a gaming tournament.
Hey, sounds good.
Give me the details.
All right, so the conference runs from time 1 to 3 and has a value of 5.
Okay.
The hackathon goes from 4 to 6 with a value of 3.
Got it.
And the gaming tournament is from time 2 to 4 with a value of 4.
Okay, I got it. So if we did the brute force approach, how would that work?
Well, you'd check each event by itself first.
Okay.
Conference, hackathon, tournament.
Right.
Then you try all the pairs.
Conference and hackathon, conference and tournament?
But the conference and the tournament overlap.
Right, they do.
So that one's out. Then you'd check hackathon and tournament.
Okay, those don't overlap
Right. And then you'd see that all 3 is impossible.
because of the overlaps.
Exactly. So the best solution is conference, then hackathon.
With a total value of 8.
You got it.
Okay, so brute force works, but it's a lot of checking.
It is.
Let's see how dynamic programming would do that.
Okay, so first we build that suffix array. Remember, we go backward.
Right.
So the tournament's maximum value is just its own value 4.
Okay.
Then the hackathon, it's the last event, so it's also just its own value 3.
Makes sense. Now, the conference is where it gets interesting,
Right, because we got to consider what comes after it.
which is the hackathon with a value of 3.
You got it. So the conference's suffix array value is its own value, 5 plus the best after it, 3, which gives us 8.
Okay, I'm seeing how the suffix array is like a shortcut.
Exactly. It saves us time.
Okay, so we built the array. How do we use it?
You'd go through each event and use that binary search to find the next non-overlapping event.
Okay.
So for the conference, you'd find the hackathon.
Okay.
Then you compare attending just the conference 5 versus the conference and hackathon 8.
And 8 is better, obviously.
Right. So even with just 3 events, dynamic programming finds the best answer.
Okay, very cool. Now I'm curious about the greedy approach.
All right, so first you sort the events by when they end.
Okay.
So we'd have tournament, then conference, then hackathon.
Right.
So the greedy algorithm would pick the tournament first, highest value, no overlap.
Okay. Then it looks at the conference.
But that overlaps with the tournament, so it skips it.
Right.
Then it gets to the hackathon, no overlap, so it picks that one.
So in this case, both greedy and dynamic programming got the same answer.
They did. But remember, that won't always happen.
Right. Greedy can miss things sometimes.
Exactly. It doesn't always see the big picture.
Okay, so dynamic programming is probably safer if you want the best solution.
Yeah, especially for bigger, more complicated schedules.
Okay, cool. Now, another thing people ask about is efficiency.
Ah.
How fast is our code going to run?
Ah.
How much memory will it use?
That's an important question.
Yeah, we don't want it to be slow and clunky, especially if we have lots of data.
Exactly. So how do we figure that out?
Yeah, so how do we even start figuring out how efficient these things are?
Well, let's think about dynamic programming first.
Right.
Remember, we're building that suffix array.
Right.
And then going through all the events and using that binary search.
Right, to find the next event that doesn't overlap.
Exactly. So for the suffix array, we have to look at each event once.
Okay.
So that takes time based on how many events there are. Let's call that n.
Okay, so the more events, the longer it takes.
Right. And then for each event, we do that binary search, which is pretty fast.
But
It takes like logarithmic time. So basically, it's related to the logarithm of n.
okay,
Yeah.
I remember logarithms.
So the total time for dynamic programming is like n times the logarithm of n.
Okay, that makes sense. And what about memory? How much space does it use?
Right. We need to store that suffix array.
Yeah.
And that takes up space based on how many events we have. So n again.
Okay, so both time and space depend on the number of events.
Exactly. More events means more time and more memory.
Okay, what about the greedy approach?
That one's usually faster.
Okay.
First, we got to sort the events by when they end.
Right.
And if we use a good sorting algorithm that takes time, like n times the logarithm of n,
Okay.
and then we just go through the sorted events one by one.
Right, and make a decision for each one.
Exactly. So that also takes time based on n.
Okay.
So the total time for greedy is also around n times the logarithm of n, mostly because of that sorting step.
Okay, but we don't need to store a big suffix array.
Right. We don't need that extra memory.
So it uses less space.
Exactly. It's more efficient with memory.
Okay, so greedy is faster and uses less memory, but might not always find the best solution.
You got it. It's a trade-off.
Okay. I think I'm starting to get it.
Good.
So we really have to think about what's most important for our specific problem.
Absolutely.
This has been awesome. I
Yeah.
feel like we covered so much about this challenge.
Me too. It's been a great deep dive.
Yeah, we went from understanding the problem to figuring out different ways to solve it, and even talking about those tricky little details that can trip you up.
Yep. We really break it all down.
So any last tips for our listeners before they start coding?
Yeah, definitely take your time.
Okay.
Really understand the problem first.
Right.
Then pick the approach that makes the most sense to you.
Okay.
And don't be afraid to try things out. Coding is all about learning and experimenting.
Yeah, I totally agree. So that's it for this deep dive into the AI.Code.Cast challenge.
It's been fun.
But before you go, we want to leave you with something to think about.
Okay.
What if you could use these scheduling ideas to optimize your own life?
Interesting.
Yeah. Could you get more done, have more fun, or learn more if you scheduled your day differently?
I like that idea.
Yeah. Something to think about.
Definitely.
Until next time, happy coding.